This is question 33 of chapter 4.4. Making silos. A grain silo consists of a cylindrical concrete tower surmounted by a metal hemispherical dome. The metal in the dome costs 1.5 times as much as the concrete per unit of surface area. If the volume of the silo is 750 cubic meters, what are the dimensions of the silo, radius, and height of the cylindrical tower that minimize the cost of the materials? Assume the silo has no floor and no flat ceiling under the dome. So for the sake of time, I drew the diagram for the silo as well as I listed out the volume of the cylinder as well as the volume of a sphere. And since we can assume that the volume of the dome is half of the sphere, we can divide the equation of the volume of the sphere by 2. And so the total volume of the dome is equal to pi r squared times height plus 2 over 3 pi r cubed. And since we know that the volume is equal to 750 cubic meters, we can substitute V for 750. Isolate for H. And to find the equation of the cost of the silo, I listed out the surface area of the cylinder's equation as well as the surface area of a sphere's equation. And since we can also assume that the surface area of a dome is half of the surface area of the sphere, we can divide the formula for the surface area of the sphere by 2 to get our dome's formula. And also, since there's no top or bottom in the silo, in terms of the cylinder, we can take out this part of the equation since that's the part that's calculating the top and bottom of a cylinder. So the total cost is equal to 3 over 2 since the dome is 1 times more costly than the cylinder, plus 2 pi r times height. And since we already have the height of the equation of the height of the silo, we can substitute H for that. Just simplifying here. And now I'm going to find the derivative of cost, which is going to equal to 10 times pi times r over 3 minus 1,500 over r cubed. And to minimize the cost of the radius, I'm going to set the equation to 0, equal to 0. And so the radius that's going to minimize the cost of the silo is plus or minus the cube root of 450 over pi meters. And since the radius can't be a negative value, the radius is positive the cube root of 450 over pi meters. So now we have this value, we can substitute it into our height equation and get a final value of 5.23224 meters. And so the dimensions that's going to minimize the cost of the materials of the silo is the height being 5.23224 meters and the radius being positive the cube root of 450 over pi meters.